All right, class, we're going to continue on with chapter 28 today. We'll finish up chapter 28 and then we'll actually start chapter 29 later on this week. So let's go ahead and jump right into negative feedback loops. Yesterday you did a quick little lab on a negative feedback loop. So we're going to learn a little bit more about what that was yesterday. All right, let me get this in presentation mode. Okay. Negative feedback loops are necessary for homeostasis. We learned about what homeostasis was, I don't know, months ago, I guess it was now. But what homeostasis does, in essence, is it just tries to keep the body at a certain temperature or at a certain particular level or whatever. It basically tries to return the body back to normal to keep a stable internal environment. So let's go ahead and take a look at this diagram here. With a negative feedback loop, I guess the best example to use would be a thermostat. I'm not sure if you guys have thermostat wars in your house, but when I was growing up, we did. So like my sister liked it really, really, really cold. I liked it kind of in the middle. My mom liked it really warm. My dad was kind of in the middle as well. And usually he had the final say, which was good for me because I liked it right in the middle. But during the day, I tend to like it kind of warmer. Then at night, I like to have it cooler because I like to sleep during or when the air is cooler. But anyway, if you've ever had thermostat wars, what happens is, let's say I like it set at 68 degrees Fahrenheit, and my mom liked it set at 75 degrees Fahrenheit. I'm just kind of making these numbers up. But what would happen is I would go ahead and turn the thermostat down to 68 degrees. So what the system does is it kicks on either the AC or it turns off the heat, right, to try to reach 68 degrees Fahrenheit in the house. However, if my mom walked by the thermostat and saw 68 degrees, it's freezing in here, I'm going to crank it up to 75, she turns the dial all the way up to 75 or hits the button until it reaches 75. So then what happens? Well, since it's already kind of cool in the house because I set it to 68, it's either going to kick on the heat or turn off the AC to try to reach that warmer temperature of 75 degrees. That's what a negative feedback loop does, essentially. It basically tries to return the temperature to whatever you set it at, whatever is the normal. So in the case of the thermostat example, the normal is whatever you set it to. So if you set it to 75 degrees, it's going to kick on the heat. If you set it to 68 degrees, it's going to kick on the AC. So that's the way a negative feedback loop works. So let's look at this diagram here. Let's start with this one. So this person is holding their breath, so their carbon dioxide levels rise. So if you suck in a bunch of oxygen, a bunch of air, you're holding your breath, then your carbon dioxide levels rise. What's going to happen is you're going to be forced to exhale because your body can't handle holding in all that rising carbon dioxide, which is why you breathe out. And then if you were Sorry, I just got a notification on my computer. It distracted me. Okay, next one. So this one is your oxygen and CO2 levels return to normal. So once you breathe out, you've breathed out the high levels of carbon dioxide, and then your levels return to normal. Now, if you were to do it again, this whole process would start all over. So if you constantly are sucking in air, holding your breath, carbon dioxide levels are going to rise, then you're forced to exhale, and then your oxygen and carbon dioxide levels return to normal. If you hold your breath again, it's going to keep going in this cycle because your body ultimately wants to be at a normal range to maintain homeostasis. Okay, what is positive feedback? Positive feedback is something that increases change. So in this particular example here, I'm going to use the example of a paper cut, some sort of cut. Let's say you get a paper cut on your finger, and it's bleeding right after you get this paper cut. There's little tiny cells in your blood called platelets, and what these platelets do is they form and collect right along the inside of your cut to try to seal it up so you stop bleeding because you don't want to bleed out from a paper cut. There's also something called fibrin in there as well, so platelets and fibrin all collect together at the site of the cut and then will actually plug up the cut so you stop bleeding. So this would be an example of a positive feedback system or mechanism because the more fibrin and the more platelets collect here, the more they're going to attract because they're really trying to seal off that cut. So the difference between positive feedback and negative feedback is that positive feedback is going to continually increase a change until you've sealed the cut or until you've reached the maximum. And then with negative feedback, it's kind of a back and forth. So it wants to return the body back to normal. So it's going to force you to do something, like in this case of exhaling your air. In the lab that you did yesterday, you had to walk with a heavy textbook on your head with your eyes open, and then you tried it with your eyes closed. The reason why it may have been easier for you to walk with the book balanced on your head with your eyes open is because you're aware of your surroundings. You can see if maybe you're leaning a little bit because you're looking, obviously, and you have a good reference of your spatial surroundings. But when your eyes are closed, it's a little harder to do because you don't know exactly where everything is. You might be leaning a little bit without even realizing it because you have no reference as to the space around you. So that is a negative feedback loop or mechanism when you're trying to walk or balance a book on your head and you're constantly kind of making micro adjustments to keep that book balanced on your head. That would be an example of negative feedback. Okay. This is just going into a little bit more detail of this particular diagram here. So your torn vessel stimulates the release of clotting factors. So your paper cut is stimulating the release of clotting factors. And then growth hormones stimulate cell division. So this is just another example here. Okay, let's go to the next one. This is 28.3 now, the very last section of chapter 28. This is talking about how the systems interact to maintain homeostasis. Each organ system affects other organ systems. So an organ system must do a specific job. I think you all know that. So like the circulatory system is in charge of circulating blood throughout your body, your oxygen-rich and oxygen-poor blood. So that's one system that works in conjunction with, let's say, your lymphatic system. Organ systems must also work together to keep the organism healthy. I feel like that's kind of obvious, but oops. Organ systems work together to produce vitamin D. Something called thermoregulation, which we've talked about before, maintains a steady body temperature. Remember, anything that has the word thermo in it usually has to do with temperature, like thermostat or thermometer, thermoregulation. So in this particular diagram here, we'll start with the UV light. So UV light is hitting this soccer player's skin. Her skin is going to absorb that UV light, and then her liver actually is producing inactive vitamin D. The kidneys are producing active vitamin D, and then active vitamin D is used in bones to help your bones stay strong. The disruption of homeostasis can be harmful for obvious reasons. But if your sensors fail, that's obviously not a good thing. If targets do not receive their messages, that's not a good thing. If you get injured, that's really not a good thing either. And illness can also harm homeostasis. So think about if you get a fever, your temperature spikes. So you might get a fever of 99, 100, 101, 102. Once you start getting into the 103, 104 temperature ranges, that's really high. And you should probably go to the hospital because at that point, that temperature for your body is too hot for some of your proteins and enzymes and can actually start denaturing them or killing them. That's all denaturing means, is killing them, breaking them down so they can't perform their functions, and therefore your body can go into failure. Short-term disruptions usually cause little or no harm. So let's say you are out running on a really hot summer day, you start to get a little overheated, you're sweating a lot because your body's trying to cool itself down, trying to thermoregulate, and once you rest for a little while, you'll be back to normal. Now, if you keep pushing yourself, that's when you go into, wow, I can't think of the term I'm trying to think of. Basically overheat. There's this fancy word for that, and for some reason I'm blanking on this very simple term. But anyway, I'll continue on. Long-term disruptions can cause more damage. Diabetes is a serious long-term disruption of homeostasis. Okay, let's look at the example here of this basketball player. So they're showing you the pancreas right here. These are the kidneys right here. So number one, pancreas cells are attacked, insulin declines. So if the pancreas cells get attacked, then the insulin levels will decline. Number two, your blood glucose levels rise. 3, your body is burning fat, and then your blood becomes more acidic. So if your blood glucose levels rise, what your body's going to then do in turn is it's actually going to start to burn fat, and then your blood becomes more acidic. Number 4, cells get impaired, and then all of your organs get damaged. So this would be like an example of someone with diabetes. And when your body burns fat, just like when you're exercising or whatever it may be, that's a good thing. But in the case of diabetes, if your blood glucose levels rise too high, that forces your body to burn fats, and fats that are necessary and fats that you need in your body, which then in turn turns your blood more acidic. And that's not a good thing. You don't want acidic blood because it will damage your organs. Okay, that is the end of chapter 28. Like I said, we are going to start chapter 29 later this week, probably tomorrow. So that is the end of chapter 28. If you have any questions on chapter 28, feel free to email me. Like I said, I'm not really going to be quizzing you after each chapter or having crazy tests or anything like that, because I really just want you guys to learn.